the t-test for paired samples. From these three paired sample tests, the t-test is more likely to detect a difference. This is one of the conditions for the paired sample t-test, that the population of differences are normally distributed. We always test the population mean difference and not the population median difference. Any zero values, so when you subtract values in their pairs, if you get a zero difference, you do not cross it out. It is included in the method. Unlike the other two tests where you would cross out a zero difference and not include it. This time we are including a zero difference, if there is one. Example 1. An area of land was sampled at 10 different points. So we've got 10 pairs of data values. The percentage of water was calculated in each of these 10 points for 1999 and for the same points again in 2000. So we're going to use a paired t-test to investigate a difference in the water content. So this is a two-tailed test using the 5% level of significance. So H0 and H1. It's a two-tailed test, so the order of subtraction doesn't make any difference. So we work out the differences, and the population of differences is assumed to be normally distributed. The differences go into the calculator. We want to work out the mean of these differences and the standard deviation for these differences. So the mean, 4.2. Option 4. And the standard deviation, 7.036. So a two-tailed test, we have t values along here. 9 degrees of freedom. The total probability to the left of this line, the cumulative probability, is 97.5%. So going to the t tables, 0.975, 9 degrees of freedom, 2.262, our critical values. Here, and minus 2.262 here. So now we need to work out our test statistic using these two values. And the formula is this. The mean difference goes in here, and S is the standard deviation for our differences. So our test statistic is 1.89. This value here comes from H0, which is 0. N, our sample size, is 10. So 1.89 is in the acceptance region. It's less than 2.262. We're going to accept H0. And our conclusion in context. Example 2, we have 8 pairs of data values. Assuming the differences are normally distributed, using a 5% significance level, we're looking for a reduction after the lagoons were built. So this is before, and this is for after. And we're looking for a reduction. So the before values will be greater than the after values. So when we're working out the differences, if we do before minus after, it should be a positive difference. So we have a one-tailed test. On the other hand, if you do the later value minus the original one, then the mean difference here will be less than 0. Yeah, that's an alternative way of carrying out the test. So we have our differences. If there was a difference of 0, we would still include that when we work out the mean and standard deviation for the differences. It's not crossed out, but we don't have any difference of 0 here. So putting this into your calculator will give you a mean and standard deviation for the differences. There are 8 pairs of values, and 8 minus 1, n minus 1, gives us 7 degrees of freedom. This is a one-tailed test. 5% in the critical region, so we look up 95%, 0.95, from the t-tables with 7 degrees of freedom. 1.895 is our critical value. And then calculating the test statistic gives us 2.263. This is our test value. So that was the mean of the differences. This value comes from H0, which is 0. N is 8. 2.263 is in the rejection region. It's greater than 1.895. We're going to reject H0. And the conclusion in context. If we had done the later value minus the original one, then H1 would be population mean difference is less than 0. So the differences here would have the opposite signs on them. Our mean difference would have been negative, and our critical region would be on the left-hand side with minus 1.895 as our critical value, and our test statistic, starting with minus 0.325 here, would have been a negative value, minus 2.263, and minus 2.263 is less than minus 1.895, so reject H0, the same conclusion. So here's the data in the calculator. The mean, and the sample standard deviation. So it didn't make any difference whether you did original minus later to have positive differences to test the right hand side tail of the t-distribution, or the mean difference is less than 0 for a negative mean difference for the sample, and being on the left hand side for the critical region in the t-distribution. Doesn't make any difference.